Alright guys, welcome back again to another exciting one. In this tutorial we will take ourselves through what Poisson distribution really means. Alright, I don't want you to get confused with all this distribution of a thing. It's just an approach that you are going to use on a particular probably data that you're about to analyze. You need to know what kind of approach you need to use for or apply on a particular data. For instance, now you can see we work ourselves through a lot. We work ourselves through a Poisson. Binomial means something that has to do with true or false. Normal distribution is general. You understand? You need to know what type of approach you need to apply, use on a particular data. So let's take a look at what Poisson distribution really means. Poisson distribution is a discrete distribution. And what do I mean by discrete distribution? It estimates how many times an event can happen in a specific time. Let's say, for instance, you are you notice that probably let's use a school as a case study. Probably a student always towards the end of probably a semester or a session, students always do a particular thing. They always do a particular thing. So how many times does that event normally occur? So if you are thinking of probably a question or something, things that you need to do that is regarded to analyzing data is in that kind of scenario, that means you can apply what Poisson distribution to that particular event. It has two parameters, like by the time you're trying to create it, you have to it has basically two parameters, and that's lam and that is size. And lam means rate of known numbers of occurrence. You need to know how many times does this thing normally occur. That's exactly what it means. Okay, so fine. Okay, without no further ado, let's dive in. Okay, so without no further ado, let's say import, but from that, let's say from numpy import random. Don't know why my keyboard is acting funny. Random. Okay, so by the time you do that, you can easily use random. Don't forget that we have been using random since we started this module. I mean this will okay, because random it give us the access to do all this kind of thing. Okay, we say random dot poison. You can see that x is 2s, so poison, not poison. Poison. All right, let's say lam, which is lam, which stands for the rate or known numbers of occurrence, and we want to say is 2. Don't forget all these things are dummy data. Okay, and we'll say size, which gives us the shape, is equals to what, 10. All right, so let's run this code and let's see whether we're going to have some errors. You can see we're moving forward. Okay, if you can do this, definitely that means you are good to go. So let's say print x. If you are printing x, what exactly is going to go? You can see this thing, it gives us a random number, but let's see whether we can visualize any data from a Poisson distribution. Okay, from numpy import random. Okay, and what else? We'll say import matplotlib. Import matplotlib dot. Okay, all right, so let's import matplotlib py plots. You know what py plot means? That's what gives us the access to plots in matplotlib as plt. And the third one is import cbon as SNS. All right, we need to run this code to see whether we're going to have some errors or not. Fine, we don't have any errors, so you can say SNS, which is a cbon dot dist plot. You need to get used to this because you're going to be using it a lot. All right, okay, we find we are going to say random because we've actually import random from numpy from the top. Random dot Poisson lam equals to size equals 1000. Okay, let me run the code. You can see it gives us something meaningful. Or I can decide to, some people in some cases they will just say plt.show. It's still the same thing, but some people will write it like that in case. All right, so you can see how it works now. We were able to understand that it is lam and size that we can use if you want to use any parameter in what Poisson distribution. And you can see we use random to actually bring that Poisson distribution into existence. And you can see you can decide to remove the probably histogram. East, let's say east is equals to what? False. All right, so can run it and let's see whether we're going to have some error. You can see it has been removed. Okay, so this is where we're going to stop for now, and hope you're enjoying this tutorial. So it is pretty easy. Just understand that you need to know what parameter all these distributions is actually going to contain, why they are important, and the reason why we're using them. All right, that is that. Okay, in the next tutorial we're going to take a look at uniform distribution, and until then, take care and have fun.